Let's see how to resolve a connection of a beam with a column using an end plate in CYPE Connect. Starting with a previously created node, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the Connection pop-up window under the Model tab, we must specify the operations required to define the connection. In this case, we click on the End Plate option to add an element with these properties. By maintaining the operation selected in the table on the left, we can configure its parameters using the options in the central panel. In the top drop-down menus, we select the section where the plate will be placed. In this example, section B1, which will be joined to section C1, and more specifically, to its bottom flange. In order to know which flange is designated as top or bottom in each section, we should use the View options. If we make the sections and plates transparent by clicking on the cells in the drawing column and activate the view of the axes in the same way, after clicking Accept, we will see that the Z-axis of section C1, shown in blue, is pointing towards the top flange. Next, we define the material of the plate. To do this, we click on the button on the right. In this case, we select S275 steel and click on Accept. Under Geometry, we define a thickness of 12 mm. The plate's type can be either rectangular depending on section, defining the overhang from the selected section, or rectangular, typing in the magnitudes of the plate directly if we already know them. In this case, we check rectangular depending on section and type in a value of 15 mm in all overhangs, top, bottom, left and right. Next, we define the bolts that join the end plate to the column. To define them manually, we click on Add to include them in the table and write their X and Y coordinates in the units shown. We also have a tool to generate them automatically. The help image shows the local axes of the plate, the X-axis in red and the Y-axis in green. Additionally, 2 rows and 3 columns of bolts are shown. In this case, we have 3 rows and 2 columns. In the initial spacings of the rows, we indicate -80, and in the spacing between rows, we indicate 80 mm, while in the initial spacing between columns, we type in -40, and in the spacing between columns, we type in 80 mm. We click on Accept. This way, the bolts appear in the table, where we can modify their coordinates if necessary. Below, we define the type of bolt. We click on the button on the right and select the ISO 4014 series and a nominal diameter equal to 14. Then, we click on Accept. Further on, we specify the material of the bolt, which will be grade 5.6 steel, and click Accept again. We set a space of 1 mm. At the bottom, we can also reverse the direction of the bolts. Then, we define the welds of the flanges and the web by activating the corresponding checkboxes. These correspond to the welds between the end plate and the section. Within each section, in the first drop-down menu, we can choose between several options to define the position of the fillet weld, on the left side, on the right side, or on both sides, as is our case. In the second drop-down menu, we indicate whether the welds are fillet welds defined by throat thickness or by side thickness, or by double bevel butt welds. In the third drop-down menu, we define the shape of the weld surface, whether it is not defined, flat, concave, convex, or with toes blended smoothly. In the fourth drop-down menu, we specify the place of execution, either on site or at a workshop. Here, we define fillet welds by the thickness of the weld throat, with a dimension equal to 4 mm. We can also set the parameters of the electrode, including its reference and the resistance of the filler metal. Finally, we indicate whether the welds have an initial or final displacement. By default, the program places the weld on the flat part of the web. interrupting the weld at the chord radius of the section. From here, once the model is finished, the user can continue their work by opening the Analysis tab in order to analyse the connection.